Good afternoon, everybody. Welcome to a rainy, cloudy Wednesday afternoon at Chem 170 with your host, me, Dr. White. Hopefully what I talk about today will brighten your day. It should. But anyways, well, it does for me. I love organic chemistry. All right, important announcement. As soon as we finish today, within about 10 minutes or less, I will send out an email with the password for test number 2 PDF file. It's available now on D2L. While we're doing that, let me check. Now, D2L, I don't know why they didn't put it out, but they have a new welcome screen and your login is all the way at the bottom, which is stupid. And I get this error page, and if you click on community at home, then you'll get back to this. Did everybody see what happened there? Did you see what happened? All right. I clicked on after you logged in, and it gave me an error page. What you do is click on My Home, and it'll take you to this new one where they talk about Zoom for Chrome update. Then scroll down, and you'll see the My interface, which should be similar to yours, where you can pick your class. So when you log in, when it gives you an error, page not found, click on My Home or the Elgin Community College symbol in the upper left. Okay? Should I say that again? When you log in, thank you for that honest answer, Christiana. Can I have that in slow motion again? Anyways, life's to be enjoyed. Luckily, I do. At least for me and hopefully for you. Ooh, I'm rhyming. All right, click on, if you get an error page, scroll to the top, and where you see the Elgin Community College logo and name, click on that. It'll take you to this page. It'll say, what? Zoom for Chromebook updates? Scroll down until you see pick the course. Now I'll go there. Let's go to view as a student, because I'm not. We'll go to assignments, and you'll see test number 2. And here's the PDF file. When you go to download it, it'll ask you for the password. And right after the lab today, I'll send it out. We'll probably be ending way early, like I normally would do if we were normally. I've been catching up, and I think we're caught up. All right, everybody clear on that? Again, after lecture today, I will be emailing you the password, and you saw the little difficulty. If I have a chance in the afternoon or maybe tomorrow, I'll contact the computer help desk and let them know that's an issue. That's part of my training as a manager. When you see a problem, you don't walk away from it. You let somebody know there's a problem there so they can solve it. Actually, I had a great boss at one company, Prat Damertz, and he was a great engineer. I think he's still alive. I haven't talked to him in decades. He moved back to Germany. And Prat taught me really how to be a senior manager. And that was one of his lessons. You see a problem, don't walk away from it. Let somebody know there's a problem. Because otherwise, how are you going to get it fixed? All right. Well, in that case, before I move on to today's lecture, I will ask, are there any questions? I'm in a good mood. I'm wearing one of my favorite shirts. Look good in it, don't I? Don't answer that. All right, let's get to work. I was talking about carboxylic acids, and carboxylic acids. Oops, got to turn on my tablet. Hang on. Do you hear that noise? It tells me I'm ready to go. So, a carboxylic acid, carbonyl hydroxyl group, R group. This is a carboxylic acid. Oh, before I do that, I got to do something. Did anybody happen to drive by a gasoline station, see it says this gasoline contains up to 10% ethanol, and think, wow, that's an alcohol? Or do you happen to go into liquor stores, places like Jewel or other places where they sell liquor? Not that I'm in any way insinuating you should purchase or consume liquor, but if you picked up a bottle of Dr. White's favorite vodka, Absolute or Grey Goose, or if you went to Costco, their French vodka, the American vodka, their cheapest one, Costco. Anyways, it will say contains ethanol or ethyl alcohol. That's an alcohol. Did you pick up a bottle of rubbing alcohol and think about that contains ethanol, not ethanol, isopropyl alcohol, which is an alcohol. And the last thing I'll ask, did you see a bottle of nail polish remover and look at it and says that has acetone and that's a ketone? Remember, when you're not in class with me, it doesn't hurt to think about organic chemistry because it's all around you. I stole that from SpongeBob. But anyways, now let's get back to work after that commercial. And by the way, I got all the rest of the semester not to give up, and I won't, to try and make you think about organic chemistry outside my lecture. All right, we talked about Iupac nomenclature. Find the longest chain with the carbonyl carbon, drop the E at the end of that name, replace it with the word OIC, the word acid, and the carbonyl carbon is always number one. And on Monday, I showed you reactions of how a carboxylic acid is a base and the acidic proton in a carboxylic acid is this. And the general reaction I did show you for this one was this. I expanded what I had on my slide. Where M is lithium, potassium, or sodium, and this is called a carboxylate anion. Stuff I'm covering now will not be on test 2, will be on test 3. And I showed you a special base, sodium bicarbonate, and I asked for this, which is quite different than I normally ask, give all the product or products for the following reaction. Remember, this is baking powder, or could be, that's one place to get it. And remember, carbon dioxide is given off as a gas. And I told you the story about the little rocket ship candy holder. The candy was awful, but the rocket was cool. My father showed me you could put vinegar, which is acetic acid, a carboxylic acid with baking powder in there, builds up CO2 pressure, and the cap fires off like a missile. Oh, is it cool? When you're 6 years old, that's cool. That was even before the word cool was being used. That's a while ago. All right, let's get to work. New stuff. I've mentioned this before, but This molecule, and I'll teach you later today or Monday how to name it, called sodium benzoate, is a preservative in pop. Now, have you ever bought sliced bread from the grocery store, and the next day after you use it, it's still good? It hasn't turned green or moldy. Why? Because they put a preservative in there, and it's called calcium propanoate. And the structure, which you don't have to know, but I do, so I'll write it for you, just in case you are interested. Calcium is the divalent cation, and this is calcium propanoate, and it's what preserves bread and other bakery goods from going moldy in a day or two or three. How that works, I have no idea. I know how to make it, but how it inhibits mold, I have no idea. Now, we'll talk later on about special carboxylate salts, anions, that are used as soap. We'll talk about that later. But one that comes to mind, can everybody see on the screen? Let me check and make sure. Everybody see calcium citrate on the screen? Here's the structure of it right here. This is the citrate anion, actually trianion, calcium plus 2 salt. And how many of you have heard you need to have calcium in your diet? Notice I go like this strong, like Arnold Schwarzenegger. But anyways, what movie did he do that in? Oh, the first Conan the Barbarian. Did you see this? The two snakes. But anyways, uh, when they say you need strong bones, calcium for strong bones, they're not talking about calcium element, which is a metal, hard like my ring, which is not calcium. It's gold. But anyways, you don't want to chew on a metal. What they're talking about is this cation helps promote strong bones. And the way you get it as a supplement, which I take, so I don't have osteoporosis, because I don't drink milk anymore, rarely do. So, and cheese, I don't eat that much. So to keep the calcium level in my body high for good bones, I take a supplement, Citracal, which is this molecule right here. I think that's the best one out in the market, but that's my personal opinion. Now, how do you make a carboxylic acid? All right, not to be confused with today's test, where primary alcohol oxidized gives an aldehyde. If you take a primary alcohol, oxidize it, you can get a carboxylic acid. Remember, bracket O, bracket means oxidation reagent, which I'm not asking you to learn the specific ones. But if you take a primary alcohol and oxidize it, you'll get a carboxylic acid. And I'll show why you can also get the aldehyde in a little while. But anyways, if you really oxidize heavily a primary alcohol, you'll get a carboxylic acid. So let's take this for a spin. So if we take this molecule, excuse me, and oxidize it, what do we have? Well, we've got a primary alcohol. and we're going to oxidize it. And you form on this carbon with the hydroxyl group becomes the carbonyl carbon, remember carbon double bond to oxygen, of your carboxylic acid. So what's my R group? This, another way of thinking of it is, here's the carbon with the hydroxyl group, this one. Do you break carbon-carbon single bonds? No. So I start with 3, I better end up with 3. And this is that carbon, which becomes my carbonyl carbon of the carboxylic acid. And there's 4 bonds to carbon. And there you go. I'm going to share the fun. And there's some fun. What would be the product or organic product or products for the following 3 points each? Everybody done? I think I missed somebody's thumb. Oh no, where did I put it? Oh, I just found it. All right, let's do it. Now, as always, when you look at a molecule, you look for what's different. What's not a, oops, somebody asked. Oh, okay. Thank you for letting me know. Hopefully you won't disappear. If not, come right back when you can. All right. Oh, quick personal note. I used to have WoW internet service. They got bought out by Astound, which has an RCN something, but they're called Astound. If you've got Astound in your area, which used to be WoW, see if you can get it. They're quite good. Watch, now I'm going to lose the internet. Oh, I'm gone. Nope. All right, let's do it. Look for what's different, what's not carbon, what's not hydrogen. Should get your attention like that. Hopefully got your attention. And we have an oxygen with a hydrogen on it, hydroxy group and a carbon. As soon as I see O in brackets, I know that's oxidation. And I should think in terms of primary, secondary, and tertiary alcohols. This is a primary alcohol. When I oxidize it, the carbon with the hydroxyl group is now my carbonyl carbon, carbon double bond oxygen in my carboxylic acid. And in this case, this is all R. And the other way of thinking of it is this carbon here is this right here. I have 4 across and 1 a methyl. And do you break carbon-carbon single bonds? No. So I better end up with 4 across and my methyl. This carbon is this carbon, which is this carbon. So I'll have a carbonyl hydroxyl group. And there's 4 bonds to carbon. And remember, it's your solemn responsibility to let me know if I make a mistake. I try not to. And that's the carboxylic acid you get. Oh, we got to do another one. And on test 3, like test 2, there'll be 3 or 4 synthesis problems. Any more would be cruel, unusual punishment, which I don't do. And therefore, what would be the starting material you oxidize to make that compound? And I should tell you, this reaction and next one, I've done for my PhD thesis, a number of them, to make certain materials I needed to use for my research. So I'm quite familiar with these reactions. Come to think of it, I've done a lot of reactions with my own two hands. All right, let me know when you're done. Thank you. Ooh, it worked today. Someone's stable still. And we'll give everybody time to finish. All right, everybody's finished, so I can get to work. All right, what's different in the product here? What's not carbon? What's not hydrogen? Ooh, two oxygens. We have a carbonyl, and that same carbon hydroxyl group, and to the same carbon are carbons. SA, carboxylic acid. And what do you oxidize to make that? A primary alcohol. So the carbonyl carbon here, you starts out with the primary alcohol carbon. Well, if I end up with 4 carbons, I better start out with 4, or you can also say this is R. R, and then this carbon will have an OH, and I'll have 4 bonds to carbon. And that's the alcohol you start with. Oh, let's do one more. Let's have some real fun. And the question would be, if you oxidize that molecule, what product do you get? And we'll give everybody time to finish. Finish. Thank you. All right. Well, what's different here? What's not carbon? What's not hydrogen? Oxygen, a hydrogen, and a carbon. It's an alcohol, but I'm oxidizing it. That's what bracket O close bracket means. And so I have a primary alcohol. And here R is methyl. And if I oxidize it, the carbon with the hydroxyl group will now be a carbonyl carbon, carbon double bond to oxygen with also a hydroxyl group, and this is a carboxylic acid. And in this case, I have 2 carbons. I better end up with 2 carbons, and I make this molecule. Now, does anybody see the significance of this reaction? If you give up, give me a thumbs up. All All right, I think you all gave up. All right, what is this molecule? CH3, CH2OH. It's ethanol. And one ramification of this reaction, if you oxidize ethanol, you'll get this carboxylic acid. And what is that? The common name is acetic acid. And where will you find acetic acid? In vinegar. Now, this is a reaction wine connoisseurs hate. Why? Well, if they bottle a bottle of wine incorrectly, get a lot of oxygen in there, guess what? Years later, when you open it up, how many of you ever heard of wine going bad? And you know what it tastes like? Like vinegar. Why? Because the oxygen, which can oxidize, oxidizes the ethanol to acetic acid. And what's vinegar? 4% approximately acetic acid. And 96% approximately water. So if you make this in a bottle of wine, with time it goes bad. Why? Because the ethanol was oxidized to acetic acid. Now, there's another thing, and this reaction teaches us. And I have another question for you. Does anybody know who's the largest consumer of ethanol in the United States? I hear the gears of everybody's brain clicking. And when you give up, give me a thumbs up. All right, one person gave up. All right, I'll give in and tell you. You'd think the largest consumer of ethanol is a company that makes alcoholic products. And the answer is wrong. The largest consumer of ethanol in the United States is a company called Heinz. You'll like in Heinz ketchup, mustard, vinegar. Why? Because they oxidize ethanol to make acetic acid, to make vinegar, which they sell, or they put in their mustard, their ketchup, or their pickle juice, the pickles they sell. They all have vinegar in them. And vinegar is essentially acetic acid and water. So next time you pick up a bottle of ketchup, mustard, or even relish, think about it. Most of the condiments you put on a hot dog or a hamburger are acidic. You know, things like ketchup, mustard, pickles. I don't know what the pH of onions are. Tomatoes are acidic. I don't like tomatoes on, well, I take it back on my hot dog. How many of you have ever had the good Chicago hot dogs where they put tomatoes and then celery salt on the tomatoes? I've been so indoctrinated, and my whole family was, when we were younger, and if my mother made a salad, she'd put the celery salt out on the table because we wouldn't eat our tomatoes without celery salt on it. All right, let's continue. Well, you're learning a lot about Dr. White. Well, I warned you at the beginning of the semester. All right, next reaction, if you take an aldehyde and oxidize it, you will get a carboxylic acid. So let's take a look at this. This is an aldehyde. And if we oxidize it, you'll get a carboxylic acid. This changes to this. Now, what you're not learning in my class, which Dr. White knows because I've done these reactions, the previous reaction, which I showed you, for today's test, you should know this goes to an aldehyde, and this can be further oxidized to a carboxylic acid. This part you don't have to know for today's test. And that's why the previous one, you can do a primary alcohol, and it matters which oxidizing agent there are. There's some that are very mild and allow you to stop here. For test 2, assume it stops here, but others, it doesn't stop here. It goes all the way here. And that's controlled by the type of oxidizing agent and the reaction conditions like temperature. But let's learn about this one for today. And this is a reaction I did for my PhD thesis to get my PhD degree. Aldehyde, oxidize, carboxylic acid. Well, let's try this out. And the question is, what's the organic product or product for the following reaction? If we look at this, we say what's different, what's not carbon, what's not hydrogen, ooh, and oxygen. Let me try that again. Ooh, an oxygen, double bond to carbon. That carbon that's double bond to oxygen, carbonyl carbon, has a hydrogen and carbons. Here's my R group. And when you oxidize it, this carbon, the R, you break carbon-carbon single bonds? No. So the R comes along for the ride, and this is converted to carboxylic acid. And in this case, remember, do you break carbon-carbon single bonds this reaction? No. So I start with 4 carbons. I better end up with 4 carbons. Here's my R group. Here's my carbon with the carbonyl, still will be. And then this becomes a hydrox group. There are 4 bonds to carbon. Remember, keep that in mind when you do test number 2, 3, 4, the final. That's always your friend. Also, always your friend. Do you break carbon-carbon single bonds? No. So that's how you do it. And here's one for you. Give the organic product or product for the following. Boy, time flies when you're having fun with carboxylic acids. And I'll wait for everybody to finish, and hopefully you will too. If you're bored, try one finger forward, the other backward, and do it at the same time. My father used to always say, a smart person should never be bored. You can find something to do. And I did. I've been doing that my whole life, trying never to be bored. And organic chemistry helps a lot. Now you know I'm an organic chemist. All right, everybody done? Let's do this. What's different? Ooh, oxygen. Remember what's not carbon, what's not hydrogen. Get your attention like that. And we've got carbon, double bond to oxygen, hydrogen. And then we've got this ring, but that's just carbons and hydrogens. So I'll call that R. When I oxidize this is an aldehyde, excuse me, I'll get a carboxylic acid. And now, what's my R group? Cyclopentane, since I don't break carbon-carbon single bonds. That will be attached to this carbon, which is this carbon, and I'll have a hydroxyl group. And that's how you do it. Oh, let's do one more. And the question would be, what would you start with and oxidize to make that product? Your turn. Isn't it nice how I share the fun? Don't answer that question. And when you're done, give me a thumbs up. I see everybody's done. Now, this is a problem, this synthesis one, I probably would never put on a test. Why? Because there's two possible answers. For this section, what do we have? Carboxylic acid. Look for what's different. Oxygen. What's not carbon? What's not hydrogen? Oxygen there. Carbonyl hydroxyl group. Carbons. This is R. And you can take an aldehyde, oxidize it. And if that's the case, R, then my aldehyde, this carbon is this carbon, and they're. Now, the reason why I would never put this on a test as a synthesis problem, because you could have also put this question down. And remember earlier I showed you can oxidize a primary alcohol to get the same product. So I wouldn't put that on a test because that's not fair to you, but in a practice, it's good. All right, let's continue on. Now, the next reaction I'm going to talk about is really cool. And I mean really cool, like really, really cool. How cool? Minus 78 degrees C cool could be. All right, here we have a Grignard carbon dioxide, and it should be acid and water. Forgot the water fell away. And you make a carboxylic acid that's one carbon longer than the than the Grignard you started with. Let's try this again. I have a Grignard reagent, and X can be chlorine, bromine, or iodine. And I reacted with CO2 and second step acid, H plus, water. And what you get is a carboxylic acid that's one carbon longer than the R group you started with. Now, why do I say this is a cool reaction? Because one way of doing it is you make a Grignard and then you put in some dry ice. How many of you have ever used or played with dry ice? Dry ice and isopropyl alcohol has a temperature of minus 78 degrees C. and I used to run reactions at that temperature. It's called a dry ice isopropyl alcohol bath. And so I'm quite familiar. And I've done this reaction also with dry ice. So let's take this for a spin. Oops. And remember the 2 under bracket H plus H2O means after you've run the first reaction, you do a second one by adding acid and water. And what do we have here? What's different? Ooh, magnesium iodide on this carbon. It's a Grignard. And X can be chlorine, bromine, or in this case, iodine, which it is, plus CO2, carbon dioxide.
Dr. White, we're still on the general reaction from the other.
What?
We're still on the general reaction from the other
Oh,
word.
no. Somebody should have told me that. All right, instant replay. Do you see this right here? All right, are you up to speed now? Can you see the Grignard? Give me a thumbs. I do see a thumb up. You can also give me the high sign. For those of you who know our gang, let's try this again. Let me back up the tape. You ever back up a tape recorder tape? That's what it sounds like. And let's start again. Thank you for letting me know, Christiana. All right. Do I feel foolish? But that happens on Zoom sometimes. I think you're seeing it. You don't see it. All right. Let's do this again. You start with a Grignard, react it with carbon dioxide, second step water. You make a carboxylic acid that's 1 carbon longer than the R group you started in the Grignard. Let's look at this reaction. What do we have? Carbon, magnesium halide. This is a Grignard. CO2, carbon dioxide. Second step, acid and water. And you add a carbon. This one, the Grignard, that's also another reason why Victor Grignard won the Nobel Prize, because here's another reaction where you can make something very special, very rare, a carbon-carbon single bond. So here's my R group, 2 carbons, I'll write it. Then I'll do this carbon here, there from the CO2. And there's my product. Notice we started with 2 carbons here. We end up with 3 total here. You make a carboxylic acid that's 1 carbon longer than the R group you start with. Now the carbon with the Grignard will be the carbon that the carbonyl from the carboxylic acid will be bonded to. And here's one for you. Thank you, Christiana. Thank you, Andrew. I better get to work. If we look, what's different, what's not carbon, what's not hydrogen? Ooh, magnesium chloride on a carbon. This is a Grignard. And X can be chlorine, which it is in our case, or bromine or iodine. Those halogens, carbon dioxide, second step, acid, and water. And you get a carboxylic acid, which is one carbon longer, this carbon, than our group you started with. What's R in this case? This. So I have 1, 2, 3, 4 carbons. I'm going to better end up with 4 carbons from that, but I'll add one more, which you get from the CO2, and this will be a carboxylic acid. And there's 4 bonds to carbon, so I know how to put in my hydrogens. And notice I started with 4 carbons, my carboxylic acid, 1, 2, 3, 4. I did it right, 5 carbons. Now, one of the things you might want to ask is, this is a rare time I'm going to do a mechanism, Dr. Always going to have some fun, is how does this reaction work? And Dr. White loves Grignard reagents, so I'm going to show you how it works. This will never be on a test. All right, Grignard. Carbon dioxide, I can write like this. If you look at this carbon, doesn't that look like the same carbonyl as a ketone or aldehyde? And you learn, hopefully you did for today's test, that the R group on a Grignard will attack the carbonyl carbon. When it does, it opens it up like this, so you get this product. And this is the carboxylate anion, which is the conjugate base of an carboxylic acid. And when I add acid and water, I'll replace this salt with this H plus. And that's how it works. Speaking about working, it's about time to take a break. So let's take a break, come back at 1:55. I'll give you an extra 30 seconds on the 5 minutes. I'll see you in about 5 minutes and we'll do the lab. And then afterward, I'll send out the password. So if you feel like it's today or tomorrow morning, whenever, you can start on test 2. So let's take a 5-minute break. Come back. All right. Guess what time it is? It's lab time. And if we were face to face after our lecture, like I just did, or today I'd be giving you a test in lecture, we go to the lab, which what we're going to do. Now, today's lab deals with distillation. And you all should see, I have Chem 1212, that should be, I don't know, I got the wrong class, but same thing, distillation lab. I hope I uploaded to 170, it's the same way, any way you look at it. And here, what's distillation? Well, what if you have a mixture of liquids, organic molecules, and you want to purify it, get a pure compound? Well, you use a distillation called purification by distillation. Now, all liquids boil. Let's take a look at what is boiling, in case you forgot from general chemistry. Oh, by the way, warning, warning, I'm going to do some artwork. You have my permission to laugh, but don't break a rib laughing too hard. Let's assume you have a beaker of water and you have a hot plate underneath. There's a control. Here's the plug. Wow, I'm doing pretty good today. And when you heat up the water or any liquid, let's just say for water, you'll start seeing bubbles in there. And those bubbles rise to the surface and collapse. And the bubbles, when it collapse, give off vapor, in this case, water vapor. If it was organic molecule, it'd be organic. And just to remind you, when the pressure of that vapor equals atmospheric pressure, when those two pressures are equal, and you take a temperature of the liquid, or actually the gas above the liquid, no, the liquid, or the gas above the liquid, that's the boiling point. Of that substance. Now, one thing you don't know about, but Dr. White does, I'm going to teach you. At home, you're used to boiling things in a metal pot or pan. I don't think anybody has any glass pots or pans. Years ago, they tried to sell them, and obviously it didn't catch on because you've probably never seen a glass one. Anybody see a glass pot or pan? Nope. Oh, I see someone has. But anyways, metal, even though it feels very smooth, has a very, very rough surface. And that rough surface allows bubbles to form. Now, when you're in glass, even when it's scratched, it's smooth. And if you don't have something rough in there, these bubbles get real big, come up, and just splash all over. We call that bumping. Bumping is bad. So how do we stop that? You put in a couple of something very rough, and those are called boiling stones. And they're made of an inert material that won't react with whatever you're boiling. And generally that's either marble chips or a very unreactive metal called carborundum. At ECC, we use carborundum boiling chips. At COD, College of DuPage, they use marble chips. Marble are cheaper, but the carborundum are better in my point, and we don't cheap out on our students at ECC, in chemistry department. So why do you put boiling stones or chips into a beaker or glassware? So it doesn't bump. Otherwise, it's go boom. I once heard about it, I didn't see it, but I believe it's true. Someone was doing a distillation, it bumped, and the thermometer from the distillation apparatus stuck in the ceiling. And it was a high ceiling. So you always put stuff in glassware. You always use boiling stones or boiling chips so it doesn't bump. Now, when a liquid boils, the vapor collects, forms bubbles. Those bubbles rise to the surface, they collapse, and the vapor keeps on going up. And when you slowly heat an organic compound or a mixture, this vapor will rise, and you can watch until it becomes a constant temperature of that vapor, and that's the boiling point. I see what I did wrong. Hold on. All right, I got the right lab up. I taught last summer the equivalent of this class at Elgin College of DuPage. They have different equipment. All right, so here is let me make this smaller. Does everybody see the apparatus for doing a distillation on your screen? I better get it on there. Now you see it. Thank you. All right, let's take a look at this. You have what's called a round bottom flask for obvious reasons. Then you have a distillation head, and then a thermometer adapter and a thermometer. Now, a couple of years ago, a number of years ago now, Dr. Daly and I talked about it, and we were able to get money to replace the alcohol or mercury thermometers with a digital thermocouple. Same thing, it measures the temperature. Then over here, you have a condenser. Now, if you look at the picture of the condenser, there's an inner tube that's isolated from the outer tube. There's an inner tube, everybody see that? That's isolated from the outer tube. And the outer tube is called a water jacket. And what you have is cold water coming in, filling up this tube called the condenser, and coming out at the top. Remember, this is very important. Water always goes in at the bottom of the condenser, comes out at the top. That's so this will fill up. If you did the opposite, put it in here, it would never fill this. It would just come down here and just come out the top here, and you just get a little water there. So it's important for a condenser, the water goes in at the bottom, out at the top. That's so that outer tube will be full with cold water. Now, have you ever taken a shower in the winter and you see a nice hot shower, and when you get out, if you don't have a good exhaust fan, your mirror's covered with fog or actually water, and that's because the water vapor from your hot shower condenses, becomes a liquid again on your mirror. Or if you're cooking in the kitchen, say you're boiling stuff in the dead of the winter, have you ever seen your kitchen window fog up? Same reason, the window is cold. Well, this does the same thing. When you heat this, and we have what's called a heating mantle. It looks like a bowl that the round bottom goes in. It's got coils you don't see. Think of it like an electric blanket, and you have it hooked up to a controller here. And you have boiling chips in here, and the vapor comes up here, goes here, because these are connected together. By the way, these are called glass joints, ground glass joints. And it's a way of connecting different pieces of glassware together in a solid seal. They're lubricated with silicone grease so they can come apart later on. But when you're using the apparatus and we use clamps to hold it in place, that will happen. Well, let me change colors. All right, everybody see the red? This is connected, so we'll go like here. And once it gets into the cool part of the inner tube, which is cooled by the outer tube, it becomes a liquid. And it comes down here to the adapter. And this is now a liquid. And that's why they call it a condenser, because it condenses. Now, if you slowly heat it up, different compounds just boil at different amounts. And by doing it slowly, you can boil off all of one compound and get it pure and do another one. And that's called a fractional distillation. Today's lab just is to teach you the basic principles of distillation. Now, one thing, I don't know if you've noticed, I'm Dr. White. Hopefully you noticed that. But if I turn off my video, you see the picture there on your screen now? What's that? It's a one-piece condenser distillation head. And here's one real time. No, I didn't steal this from ECC. When I was in grad school, I had one like this all the time. It's by Contes. Back then, it was called bantamware. It's for working with very small amounts of chemicals, really small. And a number of years ago, I saw this on sale for eBay, and I said, oh, that brings back great memories, and I bought it. Now, when you're working at this scale in our lab, we work at ECC larger amount. Here's my round bottom that I also got from eBay. Isn't that cute? It's a 15 milliliter. I don't have one here, but I've worked with 5 milliliter. That's even cuter than this. And here you have the ground glass joint that you'd have a heating mantle. You'd have a thermometer in here. And notice the tiny little condenser here, because you're only using a small amount of liquid to distill. And water comes in the bottom, out the top. And it's got an inner tube where the vapor comes up here. There'd be a thermometer in here, so it wouldn't go out the top, and come down here, and you collect it. Now, this right here is for pulling a vacuum, which we wouldn't do at ECC. That's called vacuum distillation. By lowering the pressure, you lower the boiling point. And if you have compounds that are not stable at high temperatures, decompose, by lowering the boiling point, you can distill them at temperatures that are lower. Now, another thing I should tell you about that I tell the students, how many of you have ever cooked with boiling water, like made rice or boiled noodles in boiling water? Do you fill that pot all the way to the upper lip when you're going to boil in it? No, it boils over. Well, the same thing with a round bottom. When you're doing a distillation, you never fill it more than about 2/3 or it can boil over. And then you won't purify anything. So remember, when you're distilling, one, put boiling chips in the round bottom so it won't bump, big bubbles that splash everything up and you won't get good purification. Also, you don't fill a round bottom more than 2/3 or it can boil over, just like a pot overfull filled up to the very top is not safe. Now, I have a couple of videos I'd highly recommend you watch, and I now have to make you be able to see this. Here's some YouTube I'll let you watch on your own leisure. Now, the procedure, we would construct the figure. That's the main part of the lab. It takes most of it. Unfortunately, we're at home, so you're not going to do that. but you still get a feel for what is the distillation. Now, I warn people, grease things, and before you proceed, plug anything into the wall, the heating apparatus, I have to inspect it. I make sure students put in their boiling chips. I make sure that they have their condenser connected correctly, water in the bottom, out the top. That way the condenser will stay full of water and to cool down the vapor that goes there that you're distilling. And one other thing that I warn students in this lab, they're only supposed to collect so much, so there's not going to go. You never want the distillation flask, the round bottom here, to go dry, distill everything off, because you may have stuff left over, residue, that will blow up. So you never let it go dry, because it could explode on you. Never happened to me, but that's a safety thing. All right, here you'd add 30 milliliters of hexane to the round bottom. Always use a funnel to put stuff in a round bottom flask like this. Don't try and pour it directly in. I wouldn't try it. And I've been dealing with liquids many, many decades. And, well, I hate to say that, but it's true. Then have me check it. Then I have students slowly turn on the condenser. If you turn it on like a garden hose, one of the tubes pops off and you get wet and go home wet from the water. So you turn it on slowly, then you slowly heat it. And distillations are practice in patience. You don't want it to go too fast. And what you'll do is collect the condensed hexane in a graduated cylinder, and every so many milliliters you measure the temperature. Now, we're not going to do that. And then when you're done, turn off the heat. There's a lab jack we have underneath that you can lower so it's safe, and you clean it up. Now, everybody see the data on the screen right now? If you were in the lab, this was what you'd see. And when the temperature levels out, that's the boiling point of the material you purified. And here are some questions for you to answer. And this is due next week. And with that, I'm done. Not really. I got to go, A, send out an email with the password in the next 10 minutes or less. And B, I have my office hour tonight. Now, if you have any questions while you're taking the test, email me today. Every 2 hours and about a half hour, I'll check my email. Tomorrow morning, even though tomorrow morning by 8, I'll be out and I won't be back until about 11. I have some personal stuff, but if you have questions, send an email or come to my office hour tonight. For those of you who learned the anxiety reduction method, I call the method, don't forget to use it tonight or whenever you take the test. And on Monday, I will go through all the answers for test number 2 in our Zoom meeting, but I will cut it out of the video. I'd like my special effects. But if you can't come to the Zoom meeting, come to my office hours and I'll go through it with you. If you can't come to my office hours, email me and I'll see if we can find a mutual time when we're both available so I can go through the answers with you. And with that, I'm done for today, other than my office hour. This is our last lecture of the week. I'll see you on Monday. Don't forget, take the test, upload your answers as a single PDF file. And with that, I'll say, Gang gesund. I stole that from Granny to Beverly Hillbillies. Gang gesund. Bye now.